This is a video on conservative vector fields. The question states, determine which vector field is conservative. Find a potential function for the one that is conservative. And we have the vector field f of xy is equal to 3x squared I minus 2xyj. And the vector field g of xy is equal to 6xy plus 1 I plus 3x squared minus 2y j. So to see if a vector field is conservative, we take the partial derivative of n with respect to x, and we see if that's equal to the partial derivative of m with respect to y. So let's start with the vector field f. And here, n is negative 2xy, and the derivative of m with respect to x is negative 2y. And m is equal to 3x squared, and the partial derivative of m with respect to y, well, there are no y's here, so that's just 0. So we see that n sub x is not equal to m sub y. So we can conclude that f is not a conservative vector field. So now let's find out if g is a conservative vector field. So we calculate n sub x, and the partial derivative with respect to x of 3x squared minus 2y is 6x. And m sub y, the partial derivative with respect to y of 6xy plus 1 is also 6x. So since n sub x is equal to m sub y, we can conclude that the vector field g is conservative. So now that we know that g is conservative, we need to find a potential function for g. So a potential function is a function little g of xy such that the gradient of g of xy is equal to the vector field capital G. So since the gradient of g is equal to the m comma n, we know that little g sub x is equal to m. And if we integrate both sides with respect to x, we can say that little g of x comma y is equal to the integral of m dx. Well, m is 6xy plus 1, so we integrate 6xy plus 1 dx, and that integral is 3x squared y plus x plus some constant, and since x is our variable and y is treated as a constant, this constant might involve the variable y. Now let's go back. Since the gradient of g is equal to m comma n, we also know that g sub y is equal to n. And if we integrate both sides, we can say that g is also equal to the integral of n dy. N, remember, was 3x squared minus 2y. So we integrate 3x squared minus 2y dy. And when I integrate that, I get 3x squared y minus y squared plus some constant that may involve x's, because y is now our variable. So x is treated as a constant. So now we just match up these two functions because they're equal to each other. So here we have a 3x squared y plus x. Here we have our 3x squared y, so that's there, but this one's missing a minus y squared, so that means c of y must be equal to negative y squared, and there may be more constants that don't involve x and y. So I can conclude that the potential function for our vector field capital G of xy is equal to little g of xy, which is 3x squared y plus x minus y squared plus some constant c. And I'm done with the problem.